In this video, we will discuss sedimentary rocks, how they form, what the different types are, and also how we will identify them in the lab setting. If you remember back to the rock cycle on page 6 of your reference table, sedimentary rocks are formed from weathering and erosion, and then that produces different size sediments. These get compacted, which is that squeezing together, and then they are cemented, which is that gluing together due to minerals. Okay, and again, that is right off of page 6 of your reference table. So we want to talk a little bit more about these processes today and then determine how that will affect what type of sedimentary rock that we're going to get. So if we look down at the process in our notes, we're going to see that weathering again is the breakdown of rocks. Okay, so keyword here being breakdown. We can do this through physical or chemical means. We'll talk more about that in our next unit, but just know that right now we're breaking down rock. And remember, that could be any kind of rock, whether it's sedimentary, metamorphic, or igneous. Once that rock is broken down, we're going to be left with pieces that are called sediments. Okay, now sediments themselves are just these pieces of other rocks, but we can classify them based on their size. Okay, so size is going to be the determining factor, whether you call it boulder, cobble, pebble, sand, silt, or clay, which you can see in this chart. So if you were to call a certain sediment a boulder, it would have to be 25.6 centimeters or larger. Cobbles would be 6.4 centimeters to 25.6 centimeters. Pebbles would be smaller, and then obviously sand, silt, and clay. Clay is the smallest of all the sizes of our sediments. Erosion is the transportation of sediments to a new location. So remember, weathering was the breakdown, erosion is the transport. We can transport sediments in 4 different ways. We can have running water do that. We can have wind, gravity, or glaciers do that. Okay, so depending upon the area, we're going to see transport due to these things. Eventually, those sediments will settle to the bottom, okay, and that's called deposition. So in review again, weathering is the breakdown, erosion is the transport, and deposition is when those sediments will sink to the bottom. Okay, so once we have sediments sinking to the bottom, this is when we are going to start the process called lithification. Okay, and remember that process of lithification is when we're actually going to now go from the sediments to a sedimentary rock. And there are 2 parts to that. First is compaction. Okay, so imagine a beach or the bottom of a river. You would have the water transporting or eroding those sediments, and then eventually they would settle and deposit. As more and more sediments deposit over one another, that forces them to get closer, okay? And if they're getting closer, that's going to squeeze the water out, okay? So our first step of lithification, compaction, we're going to have all of those sediments being forced together, squeezing the water out. Cementation is now when we take those sediments that are really close together with not a lot of water. The water had minerals in it, okay, and those minerals are going to fill in those spaces that you can see in this diagram. We have the loose sediment brought together, squeezed together, water leaves, but the water has minerals in it, and that's what we're going to see here. So if we watch this animation here, this is a beach, okay, and these are just a couple of sediments. So when we look here, we see this is like a zoomed in version of these sediments. Here they are, water's in between. Here are sand grains. Water's going to get squeezed out. What's left is the mineral, so all this yellow stuff is that mineral that's left over once the water goes away. That mineral acts like glue, and that's going to create our rock, which will be known as our sedimentary rock. Now in the example I just showed you, that's going to create what's known as an inorganic land-derived or clastic sedimentary rock. And these are rocks that form from fragments of other rocks. or the sediments that we're talking about. Okay, so here are some pictures of sedimentary rocks in front of you, but if you go to page 7 of your reference table, you will see right at the top here, inorganic land-derived sedimentary rocks, and then texture is clastic, and that's what we're referring to here. So you can see all the grain sizes. Here are your pebbles, cobbles, and boulders in one specific section on your reference table. Here's sand with that size listed there. Here's silt, again with the size, and here's clay with the size. For composition, they're mostly composed of the quartz, feldspar, and clay, okay, from other rock fragments. And then over here's our rock name. So how you would identify a clastic sedimentary rock is based on the size. So if you thought you saw sand-sized grains, you would just read over, and that would be your sandstone. When we look at these pictures here, this picture right here, this tan rock, if you look very closely, those are sand-sized grains, and this would be your sandstone. Okay, obviously this rock and this rock here have much larger sediments. Okay, so if we look at our reference table again, larger than sand is going to be pebbles, cobbles, or boulders. So what I'm looking at there is either a congloma or a breccia, and that's going to be determined by rounded or angular fragments. So you would have to determine that within your rock. The other type of sedimentary rock is called chemical, okay? And these are going to have a texture that's crystalline. So how these will form is either through a process called precipitation or evaporation. So precipitation is when minerals are going to fall out of solution. The way I remember this is if you think about precipitation as rain or snow, that's going to fall out of a cloud, okay? So if you're getting minerals falling out of solution, that's why we call it precipitation, because they're falling out of that salt water or whatever it might be. Evaporation is a little bit opposite. We're going to have those minerals remain as water evaporates away. Okay, so if you had salt water and the water evaporated, you would be left with just the salt that was there. Okay, so rock salt is an example. You use rock salt on your driveway in the wintertime, and that is formed through this chemical process. So over long periods of time, we can see that seas, lakes, swamps, they often have these dissolved minerals in them, and then when the water goes away or the minerals get too big and they fall out of the solution, we're ending up with these chemically formed sedimentary rocks. So if we go to our reference table here, texture is crystalline, okay, and it's a chemically formed sedimentary rock. We have 3 choices: rock salt, rock gypsum, or dolostone. And what's nice is they tell you how it forms from chemical precipitates and evaporates. Something really cool is if we look here at the Crystal Cave video, and I'm going to push play here, you're going to see crystals that formed in this cave in Mexico, all from this chemical process. So let's just do a quick showing of that.
This is just mad. Absolutely gorgeous, isn't it? This is La Cueva de los Cristales. For my money, the most spectacular cave of crystals discovered anywhere in the world.
So if we look here, this guy is standing next to these crystals that have formed deep in a cave due to that chemical sedimentary rock process. The last type of process that's going to form sedimentary rocks is organically, and the texture we're going to see is bioclastic. Organic sediments come from the remains of animals and plants. So this picture right here is of coal. Coal forms from decayed plant remains. So that would be in a swamp-like environment. Leaves or trees, any kind of plant material is going to fall to the bottom of the swamp. It's going to be compressed, compacted, and cemented over time to form this coal. Over here you'll see a limestone. If you look closely, you can see little shells in there. So this would happen in a warm, shallow sea. Corals, any kind of shell-like marine animal is going to die, and those hard parts are going to cement, compact, and cement together to form this rock. So if we look at our reference table really quickly, we're going to see that that's right below your crystalline rocks. Here you can see bioclastic's your texture. Organic is how it forms. We just slide right over limestone and coal, which were the pictures we just showed you. And limestone's unique. It can form chemically or organically, okay? So if you see cemented shell fragments, that's going to be the bioclastic version. If you don't see that, okay, it would just be kind of like a white rock that you would see. That's going to be your crystalline limestone. But the way you could tell is it would be made of calcite. And finally, how are we going to identify these in the lab? Well, the texture of the sedimentary rock refers to the origin or type of sediment found in the rock. Okay, so the first thing you want to do is look for fragments or pieces. Okay, is it clastic? Is there pebbles, boulders, sand, silt, clay? You want to look for that size, like we talked about earlier. Or you want to look for something that was living, okay, like shells. It's going to be hard for you to identify plant material in coal. You're not going to see that, but it's black, and most people know what coal look like, so that's kind of easy. Please make sure you want to know, are those really shells, okay? So a fossil can look like this, okay, and this is in a siltstone, which is clastic sedimentary rock. This is just an imprint of a fossil. That doesn't mean there's actual shells there. If they make up the rock like they do in this limestone, that means it is bioclastic because the actual living material is part of that rock. Okay, so in review, there are 3 types of sedimentary rocks. Clastic, which is just those fragments. You're going to look for the size. Chemical, remember, forming from precipitates and evaporates. And organic, you're going to look for limestone or coal. You're going to look for the actual shells or pieces of living thing within that rock.